I'm going to give you another example for finding the tangential and normal component of acceleration, where particle is moving along the curve and curve is given by r of t, and there's 4 cosine ti plus 9 sine tj plus tk. And we can write here r of t is equal to 4 cosine t, sine t, and t, and then we find the velocity r dash of t, that is equal to minus 4 sine t cosine t, and here the derivative t is 1. And we find acceleration r double dash of t, and that's equal to minus 4 cosine t, and then minus 9 sine t. Derivative of cosine t is minus sine t, and derivative of 1 is 0. Now we need some values that we are going to calculate. That is, we find r dash of t, the magnitude of the vector, the velocity, is equal to root of 16 sine square t plus 81, derivative of power of square of 8, 9 cosine square t, and plus 1. So this is our magnitude of r dash of t. Now we can find here the dot product of r dash of t dot r double dash of t. As I told you, this is an example. We're having applications of the dot product, cross product. We take dot product, we get here 16 sine t into cosine t, a1 b1 plus a2 b2 minus 81 cosine t into sine t and plus 0. And we simplify this one, we get here this is equal to minus 65 sine t into cosine t. So that is the difference of these two, and the value of r dash t dot r double dash t. Now we want to find the cross product. This r dash of t cross product with r double dash of t. So we can write here this is equal to the cross product is I, j, and k. R dash is minus 4 sine t 9 cosine t, and this is 1, and then minus 4 cosine t minus 9 sine t and 0. Now we just take the product. The I component is here is 9, 0, and become here 9 plus, get here 9 sine t I minus. For j, we're having this is 0, and this minus become plus again, become minus, and we get here this equal to, no, it remain minus because we are having the direction that's coming minus 36 here also. We are going to multiply here is okay minus this is minus 4 cosine t j. Now we have with k, we multiply this minus 36, and then we have here plus 36 plus 36. We get here this is equal to plus 36, and sine square t cosine square t. We take sine square t and 36 common, then sine square t plus cosine square t, that's equal to 1. So this gives me plus 36k. That's my cross product. We have 9 sine t I minus 4 cosine t j plus 36 sine t. Now here we need also the magnitude of this one. This r dash of t, when we find curvature and the normal component of acceleration. That formula we need this one, and we take the magnitude of this, and that's equal to root of 81 sine square t plus 16 cosine square t plus 36, and square of 36 when we take is 1296. That's the square. Now we are having all the information that we can apply a formula. Number one, we write the tangential component of acceleration. Tangential component of acceleration, and in this tangential component of acceleration, you know, in the formula we will use the dot product of r dash and r double dash, and here is our at. So our at, a formula for this one is equal to r dash of t dot r double dash of t over magnitude of r dash of t. Just substitute the values of this one that we have calculated. We are having r dash of t is minus 65 sine t into cosine t, and then we are having here magnitude of r dash of t. Magnitude of r dash of t is root of 16 sine square 16 sine square t and 81 cosine square t, 16 sine square t plus 81 cosine square t and plus 1. So this is my AT. Now we want to find AN. This is a normal component of acceleration, AN, normal components of acceleration, component of acceleration, and we denote this by AN. So this is my AN. I write formula for AN. Formula for my AN is magnitude of R dash of t cross R double dash of t, and then we just take it the magnitude of R dash of t. We have the formula for that. AN is the cross product R dash of t cross R double dash of t, magnitude of that one over R dash of t magnitude. We have calculated these values before, so we substitute the values of this R dash, R double dash, that's equal to 81 sine square t plus 16 cosine square t plus 1292 under the root. And then we have the value of R dash, just we have calculated and used in finding R of A of t, the change potential component, that is 16 sine square t plus 81 cosine square t plus 1, and that's my solution for the normal component of acceleration. So we can use these formulas for finding the curvature, and we are having the curvature, we just divide by AN square, the squared components R dash of t square, the AN we divide by that one, that's also giving the curvature. We use the formula, that is our R dash of t cross R double dash of t magnitude over R dash of t. Now this is cube. There was, in case of normal component, there was no power of that one, but here when we find the curvature, we put here in 3. So I make the substitution. I have R dash of t cross R double dash t is 81 sine square t plus 16 cosine square t plus 1926, that 30 was 36 square under the root. Now we are having here R dash of t, the 16 sine square t plus 81 cosine square t plus 1 to power 3 by 2 is the root, and then we take the power, that will become 3 by 2. So that's our curvature. So I give you the example that we can find the tangential component, normal component of acceleration, and so also the curvature. This changes for every value of t. For example, in this case, we have the trigonometric function sine and cosine. We can take t equal to 0, t equal to pi by 4, pi by 6, pi by 2, any value of t that's in the domain of the function, and we can just find the value of the curvature, normal and tangential component of acceleration at every point. Similarly, the last example, that was the example which is having the t values, that was the t square, t cube, and there we can have some value of t. So there we put the value of t, and for each value of t we can find the curvature, tangential and normal component of acceleration also. So that's the idea, that we can describe the motion of the particle which is moving along the curve with the vector value function, and we find the velocity, we can find the acceleration, we can find the speed, we find the unit tangent vector, we find principal normal vector, and then we can discuss the curvature, and then we can have at the same time the curvature and also the component of acceleration tangentially and normally. Then we get in this chapter different type of formulas for finding the curvature. We can find exactly in the same formula in the last we have done by taking the vector value function, 3 dimensions, 2 dimensions, and if it is a parametric form, we write the parametric form in 2 dimensions, and then we can describe, when we derive the formulas, and we have derived the formula in the last section. We have derived the formula for the curvature when y is equal to f of x, when r of t is equal to f of t I plus g of t j, and then when r of t is equal to f of t I, g of t j, and plus h of t k. So this is the whole thing which we have discussed. So at the end I would like to say, we are going to continue with this one, more information for the calculus, advanced calculus, especially for the engineering students, or those who are studying the multivariable algebra calculus. Very helpful for them. Then you can just subscribe our channel, and then press the bell icon also. So every lecture I have put the notes in PDF file in the description. You can click the description, you will get the file. So always I say, the important thing when you want to learn math, you have to solve the problems. There are different type of difficulties in the problem. They are same, the formula is same, idea is the same, but you have to having some activity where you can find it, because we are having variety of problems in given the calculus book. especially here in mostly at the chapter 11 or chapter 12 for the this vector value function. I would strongly recommend that you must go and solve many problems here. That will inshallah master it. Thank you very much.